Hey guys, this video is about finding angles, finding sine, cosine, and tangent of angles that aren't on our normal trig circle. So the first one here, we're going to do a sine and a tangent one. The sine one of 75 degrees. 75 degrees is not on our trig circle. It's right in between 60 and 90. So we have to use a combination of angles that we do have and our sum or difference formula to evaluate this one, and it is in your formula packet, the formulas that we're going to use. The sine and cosine are pretty straightforward. The tangent, the algebra gets a little bit more challenging, but it'll all be okay. Alright, so first of all, we just got to find two angles that add or subtract to be 75. The first thing that comes to my mind is 30 and 45. But really, you could use, let's see, 75. You could use 120 minus 45. You could use, let's see here, I don't know, that won't work, 135. 135 minus 60 would work. I'm just going to add 30 and 45. And then I'm going to go to my formula packet, and I'm going to use the sum formula for sine. So sum formula for sine says that this is equal to sine of 30 times cosine of 45, and then I keep the same sign, and so it's cosine of 30 and sine of 45. Alright, so I took that straight from my formula packet. And now it's just a matter of evaluating each of these individually from our trig circle, and then we are going to simplify it algebraically. So sine of 30, I'm going to go to 30, and sine is the y-coordinate. So this is 1/2. Cosine at 45 is going to be 45, and it's going to be the x-coordinate. Cosine at 30 is the x-coordinate. And then sine of 45 is also root 2 over 2. And now we just got to combine these. 1 times root 2, 2 times 2 is 4. Root 3 times root 3 is just root 6. And then 2 times 2 is 4. And we already have common denominators. So I'm just going to combine this into one fraction. And that is the exact value of sine of 75 degrees. Okay. Let's do one for tangent. Alright, and this gets a little bit more complicated. 255 is in between 240 and 270. 255. Yeah, 120 and 135. Alright, I like that. Let's go with that. So this is tangent of 120 degrees plus 135 degrees. And again, you can use any two combinations of angles that add or subtract up to be your the angle that's given. Alright, so the sum formula for tangent looks like this. So it's going to be tangent of 120 degrees plus tangent of 135 degrees. 1 minus tangent of u and tangent, so 1 minus tangent of 120 degrees times tangent of 135 degrees. Alright, and now we just got to evaluate and simplify. This is good algebra. This is good stuff. Alright, so what I'm going to do is I'm going to do a little scratch work off to the right to evaluate tangent of 120 and tangent of 135. Okay? So let's go over here and just evaluate tangent of 120. It's going to take a little bit of work. It's the y-coordinate divided by the x-coordinate. Those both look like the y-coordinate divided by the x-coordinate at 120 degrees. So the y-coordinate is root 3 over 2 divided by negative 1/2. It's going to be, let's see here. Alright, really, the easiest way to think about this is that the 2's are just going to cancel out. and it's negative root 3 over, or root 3 over negative 1, which is negative root 3. Alright, let's do the same thing for tangent at 135. This one's easy because they're both root 2 over 2, but one's negative. So when I take, I'm just going to get negative 1. Okay. Alright, so let's use that in our formula. So tangent of 120 is negative root 3. Tangent of 135 is negative 1. 1 minus negative root 3 over 2. I don't know why I did that. 1 minus negative root 3. And that is negative 1. A lot of negative signs. Alright, let's clean that up. This is, let's see here, it's negative, I'm going to do it down here. Negative root 3 minus 1. And this is 1. 1, 2, and 3 negatives. It's going to make a negative. Alright, we're not done. We've got some work to do. This actually simplifies even more because we do not like this square root at the bottom of this fraction. So what we're going to do is we're going to multiply the top and the bottom by what's called the conjugate of this denominator. So if it's 1 minus root 3, we're going to multiply the top by 1 plus root 3. So you just switch the sign and multiply the top and the bottom by that, by the conjugate of this denominator. Alright, and this is going to simplify really nicely. I'm going to use the FOIL technique for the top and the bottom. Okay, so the FOIL on the top, do the top first, is negative root 3 times 1. The outside is negative root 3 times root 3, which is negative 3. Inside is negative 1, and then the last is negative root 3. On the bottom, the first is 1. The outside is positive root 3. The inside is negative root 3. And the last is negative 3. Oh yeah. Alright? What's nice about that is we got rid of the square roots on the bottom of the fraction. That's why we did it. Alright, so what I see here is I see a negative 4. I also see a negative 2 root 3. And I also see a negative 2. Let's see here. We can, what's the best way to think about this? Alright, I like this. Because they're all negative, I'm going to factor a negative 2 out of the top. Pull a negative 2 out of this. So if I pull a negative 2 out of that, negative 4 divided by negative 2 is going to leave a positive 2. And then a negative 2 divided by a negative 2 is going to leave a positive 1 root 3. And I like that because it makes it really clear why we can cancel out those negative 2's. So that actually simplifies really nicely. Alright. My last note on this is you're going to see patterns in all of these problems, alright? Because when we, like, the first one we did is we took, we went 75 degrees. Sine is 75 degrees. So all we did was we found sine of that triangle. It's probably hard to see, but oh well. And really, if I find sine, cosine, or tangent of any point of any of these points around the circle, these in-between points, it's just the same triangle I just drew, flipped, rotated, but the side lengths are going to be the same. So all the ratios, the sine ratio, the cosine ratio, and the tangent ratio are all going to be a variation of one another, but they're all going to look similar. So you should expect when you're doing all your tangent calculations, you should expect something like that. The simplifies really nice. And when you're doing your sine and cosine, it's gonna be something like this, where it's root 2, root 6, positive, negative. It's usually it's always over 4. There's patterns you should expect. It'll help you know if you did it right or wrong. All right, that's cool.